Unit 3. 3.1 Size and trend of world population growth. Rapid and dramatic growth rate of the world population is known as population explosion. Population doubling time is the time taken, in years, for a population of a given region or country to double at a given rate of population growth. The lower the growth rate, the longer is the doubling time, and the higher the growth rate, the shorter is the doubling time. World doubling time is 46 years based on 1.53% annual population growth rate. Population annual growth and doubling time. Africa 2.59%, 27 years, L. America 1.73%, 41 years, Asia 1.62%, 43 years, Oceania 1.49%, 47 years, and America 1.07%, 65 years, Europe 0.23%, 304 years. Africa has the fastest population growth rate in the world. Africa has the shortest doubling time, 27 years, based on 2.59% annual growth rate. America has the second shortest doubling time, 41 years, based on 1.73% DT. Europe has the longest DT, 304 years, based on 0.23% annual growth rate. Europe is the only continent its population annual growth rate is less than 1%, 0.23%. Europe and Africa have shown very contrasting, opposite doubling times. Top 10 populous countries are China, India, USA, Indonesia, Brazil, Pakistan, Bangladesh, Nigeria, Russia and Japan. Ethiopia is the 11th most populous country in the world. Population growth in less developed nations occurs at a much faster rate than in the developed nations. As of 2000, 1.2 billion people lived in the developed nations of the world, and 4.9 billion people lived in the less developed countries. Asia contained 58% of the world population. Africa had 13%. 3.2 Components of population change, dynamics or determinants. They are fertility, mortality and migration. Fertility and mortality are biological factors, while migration is purely non-biological. Immigration and birth are positive factors, which tend to increase population size, while emigration and death are negative factors that reduce population size. Fertility. Fertility is the actual occurrence of live births in a given population. Measures of fertility. O crude birth rate, CBR. O general fertility rate, GFR, and O total fertility rate, TFR. A. Crude birth rate, CBR. It is the number of live births observed in 1 year among 1,000 people in a given region. It can be expressed as a number of live births per thousand people, where B is the total number of live births during a year. P is mid-year total population. K is a constant, conventionally 1,000. Example: if the number of live births in a population of 70,686,000 was 270,300, the crude birth rate is CBR equals 3.8 births per 1,000 per year. The weakness of the CBR is, it is crude because its denominator includes all persons, regardless of their contribution to fertility birth. B. General fertility rate, GFR. GFR measures the number of live births in a year per thousand women of reproductive age, 1549. It is calculated where B is the total number of live births during a year. P1 is mid-year population of women between 15 and 49 years age. K is a constant, conventionally 1000. Example: the estimated mid-year population of a given country in 2000 was 50 million, of which women in their reproductive ages constituted 1/5. In the course of the year, there were 500,000 live births. Calculate the general fertility rate of this population. Given number of live births equals 500,000. Number of women in their reproductive age was 1/5 of total population equals 1/5 times 50 million equals 10 million. Equals 50 per 1,000. This shows that 50 children were born for every 1,000 women in their reproductive years. GFR's weakness is that it does not account for differences in age groups. Each age group is not equally fertile. See total fertility rate, TFR. TFR is the average number of children that would be born alive to a woman during her lifetime if she were to pass through all her childbearing years. TFR is the sum of the age-specific birth rates, 5-year age groups between 15 and 49, for female residents of a specific geographic area. Formula: sigma ASBR times 5, where sigma is summation of ASBR is each 5-year age-specific birth rate defined as, where Bx is the number of live births to mothers of age X. Px is the number of resident women age X. The values are age group represented by Bx 1519, 2024, 2529, 3034, 3539, 4044 and 45 plus. The values are age groups represented by PX are 1519, 2024, 2529, 3034, 35 to 39, 4044 and 45-49 years. The sum of these ASBRs is multiplied by 5 because each ASBR represents a 5-year cohort of women. The number of children born to women in developing countries is much larger than to women in the developed regions. Factors of fertility distribution. Age at marriage. More children are born to girls who marry early. Status of women. Education usually offers women access to information about how to limit family size, increase their marriage ages, use contraception, etc. Socio-cultural factors. Religion, ethnicity and family structure. Sex preference. The desire to have children of one sex over the other. How can birth rates be reduced? Improved status of women, including their rights to decide between the use of birth control and having children. Improved educational levels regarding family planning, particularly for women. Improved access to family planning supplies. Mortality. Mortality is the occurrence of death. Mortality rates, though decreasing worldwide, are higher in the developing countries than in the developed ones. This difference is caused by variations in standards of living, nutrition, medical services, personal hygiene, and environmental sanitation. Measures of mortality. Crude death rate (CDR) is the ratio of the total registered deaths of a specified year in a region to the total mid-year population, multiplied by 1,000. OCDR is crude death rate. OD stands for total observed deaths. OP is total mid-year population, and OK is a constant, 1,000. Example. In a hypothetical region, the total number of deaths observed in 2006 was 60,000, and the total mid-year population was 12 million. Therefore, the resulting CDR was equals 5/1000ths. It indicates that the deaths of 5 persons were observed for each 1,000 people. 2. Infant mortality rate (IMR) is the number of deaths of infants under the age of 1 year per 1,000 live births in a given year. Example. A total of 400,000 babies were born in a certain region in 2010. Of these newborns, 340,000 babies survived their first year of life. Calculate the IMR of this region. Deaths under age 1. 400,000 340,000 equals 60,000 babies. Out of 1,000 children born in the year 2010, about 150 infants died before celebrating their first year of life. Infant mortality rate is a good indicator of the level of development of any country. Developed countries characterized by low IMR because of better living conditions. Less developed countries characterized by high IMR, due to malnutrition, various diseases and poor environmental sanitation. Life expectancy is the number of years a newborn is expected to live. It tends to increase with standard of living. Migration. Migration involves movement of people. The most common measures of migration that can affect population growth of an area include a immigration rate. It is the number of people arriving at a destination per 1,000 people in a given year. Immigration rate. B. Emigration rate. It is the number of departing people from an area of origin per 1,000 people of the area of origin in a given year. C. Net migration rate (NMR) shows the net effect balance of immigration and emigration in an area. It can be expressed as an increase or decrease per 1,000 people in the area in a given year. Example. Suppose the number of emigrants and immigrants of country A are 40,000 and 250,000 respectively. If the total population is 105 million, what is the NMR for country A? 2/1000ths, i.e. 2 per thousand population. Measures of population change. Rate of natural increase, RNI, it is the difference between birth and death rates. Hence, it is a naturally caused numerical change of a population which results from the interplay between fertility and mortality. It is expressed as RNI equals BR, drive. Example. If the birth rate and death rate of a certain country were 50 per thousand and 28 per thousand, respectively, what was the rate of natural increase, RNI? 3.3 Population structure. The structure of a population is the distribution of males and females within different age groups. Data on population age-sex structure is ideally collected through census, reflecting a complete population count. A population pyramid, also called age structure diagram. It shows the distribution of various age groups of each sex in a human population. The population of a given country can be grouped into three categories. Young dependents 0-14. Elderly dependents 65 plus, working age groups that are economically active 15-65 years of age. The proportion of the three age groups varies from region to region and among countries. Most developing countries have a large proportion of young age group population. Developed countries have large proportion of adult and old age group population. Different characteristics of a population pyramid. A wide base indicates a high birth rate, and a narrow base indicates a low birth rate. Developing countries' population pyramid characterized by wide base, narrow top, indicating a high birth rate and a high death rate. Developed countries' population pyramid characterized by narrow base and wide top. This indicates a decreasing population trend. The low birth rate is indicative of a well-developed country. Concave sides indicate a high death rate, and convex sides indicate a low death rate. The population pyramid of Ethiopia exhibits concave sides, indicating a high death rate. Sex structure or composition. Sex ratio, SR, it is the number of males per 100 females. Sex ratio is expressed in percentage or ratio form. Dependency ratio. The age dependency ratio, ADR, of a population indicates how many people are dependent upon every 100 workers. People between 15 and 65 is the workers of a society. Economically active people under 15 and over 65 are considered dependent upon the working population. 3.4 Spatial distribution of world population. The most important characteristic feature of current world population distribution is its extreme unevenness. 3.4.1 Factors of population distribution. The extreme current unevenness in population distribution is due to these factors: ecological, physical factors, socioeconomic factors, political factors, demographic factors. Areas of very high population concentration. Asiatic population belt supports more than 60% of world population. East Asia, China, Japan and Korean Peninsula supports 25% of world population. South Asia India, Pakistan, Bangladesh, Myanmar, Burma, and Sri Lanka supports, accounts for about 25% of world population. Europe, more than 10% of world population. American cluster. Northeastern part of the USA and Canada, supports about 5% of world population. 2. Sparsely populated areas. Hot and humid region. High relief areas, areas with poor soil. 3.4.2 Population density. Population density, also termed as the spread of population over space, area. Accrued density or arithmetic density is a measure of the number of inhabitants per unit